Okay, so I have a FITS file now that I can open, or a FITS file process that I can open. I want to put this in a function because I'm going to have to do this 3 times or constantly. So I'm going to turn all this into a function. So I'm going to cut and I'm going to paste this into a function. I'm going to call it, data equals process. I can't spell. Process fits data. Data file name or something like that. Okay, so all that's going to go in there. So instead of file name, that's going to be this. So that should do everything, and it'll give me my image data back. I'm going to change this back to 255, and then if I need to scale the data, I can scale it back in my main. I don't care that it doesn't like this. It's just going to have to deal. So I think I'm happy with this. I'm going to save it. Obviously, make sure it saves in the same function or the same folder that you're in, process fits data. So if you missed this, this was another video that we just wrote. If you're just looking at first time, just pause the video, type this up right quick. But this is how we download the data. We got this data by Googling something about downloading FITS data. We went download FITS files, and then I went down to the Noir Lab. And the Noir Lab had, whoa, not that. The Noir Lab had some things, and I think I downloaded the Eagle Nebula, which is the Pillars of Creation, and I downloaded that file. So basically, that should get you caught up if you somehow missed the other video. Let's see. So here I am. Let's just make sure this still works. So if I go image data equals, I already forgot the name of it, process fits data 502 nmos.fits. Oh gosh. Thank you. Control C to stop doing that. That thing. Okay, so now I need to remember that I had to image data equals image data divided by 2. Let me just do that. Okay, so now it's coming back in again. Okay, so it's too big, so I'm scaling it back down because it's too bright. Okay, so we're making some progress here, but now what we want to do is we want to bring in those 3 other wavelengths. So remember that whenever telescopes take pictures, they take pictures at different wavelengths, and whenever you're seeing, artists, not even artists, but astronomers' versions in these pictures online, they're putting all these pictures into the different RGBs, and they're playing with it so that they can bring out what they're looking for. It's not that they're manipulating the data, they're just like, I'm trying to specifically look at this aspect of it, so blah, blah, blah. Okay, so I'm going to call this, instead of calling it image data now, I'm going to call it 502 data, shift enter. But I'm going to get rid of this. Okay, so I'm going to pull in the same stuff, except I'm going to do 656 N data is the same thing. 656 nmos. And then I'm just going to leave it for the moment. Maybe I should go ahead and IM show it just to see what it looks like. Oh, goodness. Why you got to be like that? Oh, you know why? It's because I can't start a variable with a number. It's almost like I completely forgot that Matlab rules exist. And it was in red, and it was totally telling me. That's really funny. I'm kind of an idiot. Data 502. It's literally a question my first test. Oh, wow. This is what I get for being dumb. Okay. Okay, so that one's too bright, so I'm going to do the same thing. Data 656 equals data. 656. I'm going to laugh at that for like, oh, come on. Let's divide by 4. Oh, let me try the color map. Spring. Oh, so see, now you see different stuff is coming in, right? Why are you yelling at me? Oh, I can't spell color map. Okay, so this is a different kind of picture, right? So you see the different things are coming out. That's because it's at a different wavelength. And see, nothing comes out at 2. 8. Oh, see now, that's different picture stuff. Isn't that cool? You're like, shut up. Okay, we're gonna do this again. Data 673 equals process fits data 673 and MOST fits. Okay, this is too fun. And I imagine I'm gonna have the same problem whenever I try to do this. 673. Yeah, it's too bright. Ooh, okay. So you see we're getting different information from each wavelength. So now what we want to do is put it together. So this took me a while, embarrassingly long to figure out, but essentially what you can do in IMShow, like, is you can give it data that is in the RGB like setup. Is it going to tell you this? No. It just is a grayscale image, XMap, color map, file name, graphics file, IMG. Okay, so it says IMG may be a grayscale, RGB, or binary image. So what we've created here, or what we can create, is an RGB file. So my fancy file, and we haven't really done this, is I'm going to create a 3-dimensional matrix. So like this is a 2D matrix. This is like, think about it like this is the first page of the index card. This is the second page, and this is the third page. So the first page is the red. We're going to show in red. The second page we're going to show in green, and the third page we're going to show in blue, I think. Please let me know in the comments if I'm doing something wrong, because I literally just figured this out and I was just too excited to make sure everything worked before I did it. But the way that you do this in Matlab is you're going to show all rows, all columns, first page equals this data. And we're going to show that in red. All rows, all columns, second page, we're going to do this. And I just like typing. All rows, all columns, third page, that. Okay. So in theory, and you don't do the color map here because it's going to automatically do it in RGB. Okay, I'm really scared. I'm like really scared. Let's just see what happens. Oh my gosh, I got a picture. Oh my gosh, oh my gosh, oh my gosh. I got a picture. I got a picture of science. I got so much science going on. This is crazy. Oh my gosh. Okay, so RGB. The blue seems super bright, so let's make it darker. Wait, I don't know what color I just did. That seems like I made it weirder. Oh yeah, because the blue went away, so it's less purple. It's more red because the R is really bright. I'll just make everything equally dimmer. I can't spell. Ooh, now it's super green. Okay, so the green is too much. Okay, so these guys need to be, so basically now it's just a question of playing with these numbers until you get a picture that you like. Isn't that cool? Isn't that kind of neat? I like it. You can also change the order. So if you're like, I'm really not digging how the green is super green, you can change these. Ooh, now it's a pink existence. So remember when I was showing you the thingy with the color map, educational color map, color a galaxy, I forget what it was called. Oh goodness. It was with a telescope. That's not how it was working. Color a galaxy. NASA's wherever it was. I forgot what I was Googling. There was a play. I was playing with it. Anyway, hold on. I can find this for real. Color, galaxy, coloring, workshop, coloring, Chandra, creating your astronomical image. Oh yeah, it was on the Rubin Observatory website, where you can do this and you can play. So they have like more filters that you can do, and I haven't figured out how to do that yet in Matlab, I guess was my point. And they can also like stretch of like, well, where do you want the granularity of this to kind of happen? And I haven't figured that out yet either. But what I think is happening is when I divide by 8 or multiply by or divide by 2, I'm changing where this scroll bar is. And if I would change the order of these, that's whenever I'm changing the order of these here. But anyway, I just thought this was really fun and kind of cool. So you can change, ooh, I don't have anything in red. Ooh, so I'm just gonna go back to this for the moment. Even though I do dig the purple. I kind of super dig the purple going on. But anyway, you can kind of play and mess around and decide, you know, what it is that you want to emphasize, what it is that you like. And so that's kind of cool. And you can make all the pretty pictures that you. Ooh, it's green. It's super green. Ooh, I like that even better. Oh my gosh. See now, okay, so this is a perfect example of what I was trying to say whenever people are like, it's false color images. Okay, so see, like, you can't see as many different kinds of details, but maybe you're specifically looking for stuff, but then if I go here and I divide by 100, I can be like, oh my gosh, look at this little thing here that I couldn't see before. It's not that I'm messing with the colors to manipulate you into liking science. I'm messing with the colors because I'm studying different parts of this thingy, because in theory I'm an astronomer and I know better words for these things than just thingy. Does that make sense? So you use the false color to bring out different aspects. That actually looks really good. I'm gonna like look how pretty that is. So you can make pictures like this, and the reason that you do it is because, see, now you can see the thingy, I don't know, the pretty space stuff, doing stuff in the background. So it's really, really cool. And then you can save this. But again, the idea is that all the information is there. So now that I have this, if I go and I save this as a JPEG, the information is lost, you know, and I can't do adjustments. But the astronomers like that raw data because then they can make adjustments and they can decide what they're really focusing on, just depending on it. So I hope you had fun. This made me so happy to do.